Alright guys, so in this video we're going to talk about how Visual Basic 6 handles callback functions in PCode, how it exits the bytecode stream and then re-enters the PCode stream for a callback, and then how it goes back again to the C. So we've already looked at the declare API mechanism in the previous video. So this one, we're going to skip over that part of it and we're going to just focus on the callback part. So this is as small of a program as you can basically get. We have an import that takes a callback address and an argument. That we basically just pass it the address of our callback and a value of 1, and the DLL itself is also as simple as you can possibly get. It just exports the one function, and then it uses the callback with the argument passed in and returns the value from it. So, I mean, if we run this, basically we're passing it a value of 1, 1 plus 1 is 2, returns that, returns it to the C, and then the C sets it here. So we're going to see a value of 2, okay? Simple as it gets. Now, we've already compiled this in both PCode and standard code, native compile. So first we'll look at the native compile, and we did it with symbols again. Here we can see that we're pushing the offset directly of my callback. And if we go to my callback, we see we're loading the arg, we're adding 1 to it, and then we're just EAX is the return value. So it's basically everything that we expected to see just in a standard native code. Nothing unexpected, although there is like an overflow check, but that's just part of VB. We can actually compile that out if we wanted to, if we change things. So if we compile this as PCode, and then we look at the disassembly of the PCode now. All right, so we see we're pushing a literal value of 1 on. We're getting the address. We're loading the reference to module 1. Proc, whatever. And then we're calling our import through that. Now, if you look, everything looks pretty standard. Everything looks like we would expect it to be. We do have a function at that address, and, we're loading the argument. We're loading a literal 1, we're adding the 2, and then we're saving it. So everything looks, very straightforward, but it kind of can't be that straightforward if you think about it, because, we're in like a PCode stream here. So how does it really, we can't just go passing, we can't go passing a CDLL the address directly of a PCode proc. It won't know what to do. This is really just data that needs to be interpreted. So there's a little bit of hidden stuff going on here. So I'm going to start up the debugger, and I'm going to hit F7. We can see that our value of 1 is passed as expected, and we're going to hit F7 again, and we can see that the value, the address of that procedure is not what was passed onto the stack for us. Here we see a different address was being passed by this opcode. And so what does that represent? And that is kind of the interesting part of this whole query. So let's see, I'll stop debugging here. We have the information that we need. I have that PCode file disassembled, and here is that address. And we can see that there's this little stub that's been compiled into our executable. And here it is, it's pushing the address of something. Or it's moving it into EDX, and then it's taking this other address, which we can see is the set to a jump to the proc call engine ordered by the VB runtime, and then it's going to jump to the proc call engine. It's going to jump to that address, which will then jump to the proc call engine. So what is this address here? 401510. So if we go back to our, VB deck here, and we take a look at this function, we can see that this 401510 is actually what we have as the raw address of this function. Now, each PCode function actually has like kind of a postfix header after the function, that details some different characteristics of the function. And so that's what's being passed to the proc call engine, not the start address of the function, but kind of the header at the end. And VB, that's what VB needs in order to load it and enter the bytecode stream for this. Now, if you think about what I just said, if you think about what that is, there's some interesting things that you may be able to do with this in the future. And so that's just a little egg to, you know, where we might be going with this in the future, depending on how honest you boys and girls are. And if I want to drop those, because, I mean, not everybody's awesome. So anyway, so we kind of want to watch this in action a little bit, right? So we have our debugger set up here. We have IDA set up, and what we want to do is we're going to set a breakpoint on, let's see, where is the most interesting place to set it? I set probably on add I4, so I'll see where I have it set. All right, so I have it set at the exit proc. I don't know if that's quite what I wanted to do. Because that's not what I wanted to do, actually. What I want to do, hold on a second, to my friends, I want to show you just before it goes into, so I want this imp add call I4. So let's see, we'll do a find and we'll do imp add call. We'll do the I2. I'll set a breakpoint there. So this is going to be the entry to call our API function. All right, imp add call I2. Now we're going to step through just a little bit more than what I was thinking, but it's, so we're calling EAX, and what this is going to be, you're going to recognize this in a second if you watch the first video. So this is how our, if you look, see, there's my function, and then here's the DLL and stuff. So what we're stepping through right now is how it's going to transfer execution into our CDLL. So here is our DLL call. This is going to load the address of it, and then this is going to jump to, now you can see we're in our DLL function, and it's compiled in debug mode, so you have to deal with the extra jump. So now here we are in our CDLL. We're getting ready to do the callback. We'll go through the prologue, and then here is our callback function. So this is the part that is interesting because we're in native code now, and now we're going to hop to that little func that we, not really a func, the, you know, this little stub that we saw. So here we are at this little stub, 4010 F4. And again, this is the offset of the end of our PCode function. And then this is, well, it's not showing well, but that is going to be the jump to the proc call engine, and we'll see it in a second. And here we are, there is the proc call engine. So the VB runtime proc call engine is what is doing, I'm not going to step through all of this because this one, this gets a little bit complicated how it sets up the frame based on the data in that function to enter the PCode string. I'm just going to go through real quick. It's not hugely long, but it's long enough that I'm not going to explain it all to you. And I haven't even like really analyzed it well enough to describe everything that's going on at this point. That's going to be some fun into the future. But here you can see, here is where we've loaded our first opcode of the stream, and now we're entering, after all that setup that we did, now we're getting ready to enter the PCode stream. And here we are, fload add, and if we look at our first instruction here, the name is different. They've changed the names on these over the years. So it really depends which version of debug symbols you got, but it's opcode 6C. And if we look at AL, here's opcode 6C. So we are looking at the same thing. So now we're going through our different opcode stream. It's just gonna, and I do have the breakpoint set at the end, so I'm just gonna continue till we hit our exit proc. So after that, it kind of just goes through. I'm gonna step over that, and now it's doing the cleanup. And clean up. All right, and then the jump ECX, and we can see that ECX is an address in another DLL, and actually it might still be to runtime. No, it went back into the DLL2. So here is where we called our function pointer, and what is that going to be? It is not. I did not disassemble this. This is probably like a. Those are just checks. And then here is where we want to go. Now we're back into the runtime. So our API call returned back into the runtime. And if we scroll up, we should see here we are again. We're at the end of our imp-add call I2, which led to our API call. And then here we are ready to enter the bytecode stream again. And our bytecode is 71. And if we go to here at submain, we can see bytecode 71 as we're getting ready to enter the bytecode stream again at this point and continue on with the rest of our program. So that gives you a little glimpse into how we've transferred from, we started in the PCode, we went to HEDLO, we went to a callback back into PCode from the ZDLO, back into the runtime to the return of this, and now we're back into the PCode stream yet again. So it's interesting to see where they put these little, just in that example, there were 2 sections of embedded native stubs in the Visual Basic 6 PCode executable in order to kind of help glue everything together and help with the entering and exiting of native code again. So that's interesting to understand that mechanism, and there may be some interesting things that we could do with it into the future if you're creative. All right, so that's what I wanted to cover, and in the next video we may be getting a little rowdy, a little creative. All right, so we have enough foundation, and moving on.